Okay, now let's look at the volume and surface area of a cylinder. Okay, so you have three different scenarios for a closed cylinder, which means I have both the top and the bottom. In my surface area, okay, 2 pi r squared because I have one circle on the top, one circle at the bottom. Okay, what is this 2 pi r h? Okay, this 2 pi r h here, this is your curved surface area of cylinder. Okay, for your volume, okay, it's just base area times height. So pi r square times height. Okay, the only difference for open cylinder, the second scenario, is just that you don't have this 2 in front of the pi r square because I only have the bottom area. Okay, the rest are exactly the same. Okay, then for hollow cylinder, which means I don't have the bottom as well as the top. Okay, the only portion I'm looking at is the curved surface area. Okay, so you all can think of a cylinder as a stack of pancakes. Okay, because you are stacking them. Okay, and then all of these pancakes are exactly the same. Okay, then you slowly add them up. That is what accounts to the height of the cylinder itself. Okay, so let's take a look at example 13.3a. Okay, you have a flat cylindrical metal pipe, okay, with an inner diameter of 13 cm. Okay, so that means this inner circle here. Okay, and an outer diameter of 19 cm, which is this outer diameter here. Okay, length of 3.6 meters. So this 3.6 meters, this is your height of your cylinder. Part A, find the volume in cm cube of the metal used in the pipe. Okay, so take note, exams they like to give you this trick. Okay, this is in cm, this is in cm, but this is in meters. Okay, so always make sure that all of the measurements are in the same units. Okay, if they are all in cm, only one in meter, convert all to cm, please. Okay, don't use this 3.6 meter as 3.6 cm. Okay, so I convert the height in meters to cm. Okay, 1 meter is 100 cm. So you just multiply by 100, you get 360 cm. Okay, the volume, okay, this is the special portion. So because you are looking for the volume of this cylindrical metal pipe, I have a hollow cylinder inside. Okay, I need to find the volume of this big cylinder minus the hollow portion inside. Okay, so volume of your cylinder is pi r square h, right? So they ask you to take pi as 3.14. Okay, so that is the value that you use for pi. So pi times r square. Okay, because 19 is your diameter, radius is diameter divided by 2. So 19 divided by 2 bracket square times 360, which is the height. Okay, then next you find the inner volume, which is the hollow portion here. Okay, use the radius of 13 over 2. Then you just subtract the inner volume from the entire volume to get the actual volume of the metal pipe itself. Okay, so in your exams, okay, you just write out all of the values you see in your calculator. Or what you can do is just write out to 5SF. Okay, but your final answer must always be in 3SF. Okay, so if this was an exam question, okay, I write out what I have in the calculator first because you might use this in the next part. Okay, you never know. Okay, so write it out. This is in this case, okay, they wrote up to 7SF. Okay, or you can write 2dp. Okay, then I'll put an equal sign, round up to 3SF. So it will be 300 3SF. Okay, sorry, the units as well are cm cube. Okay. Okay, part B, you're asked to find the inner curved surface area of the pipe, which means this inner portion here. Okay, so the radius that you should be using is 13 over 2. Okay, so your curved surface area formula is 2 pi r h. Okay, so 2 times pi times r, which is 13 over 2, because I'm taking the inner portion, times 360. Okay, you get this value, same thing. Okay, round it up to 3SF for me. So it will be 14700 cm squared, 3SF. Okay, so this is your first example. Okay, so this one is quite straightforward because you just apply the formula that you have learned. Okay, let's take a look at the next example together. Okay, so the next portion that you have here, recasting of solids. Okay, so now you have to apply the formula that we have learned. Okay, so when I recast a solid, okay, essentially I'm changing the shape of the solid. Okay, so change of shape. Okay, that means maybe I will melt the current solid that I have and change it or form another shape with it. Okay, so key thing, put a star here. When I recast or melt a solid, your volume remains the same. Okay, then when I paint a solid, okay, we are always painting the surface area, right? Because when I paint something, I'm always painting the outer portion of it. I don't go and paint the inside of it. Okay, so let's take a look at this example together. I have a rectangular brick, okay, measures 18 by 9 by 6. Okay, find the number of bricks required to build a rectangular wall, which is 4.5 meters wide, 18 cm thick, 3.6 meter high. Okay, same thing, different units. Okay, this is meters, this is meters. Okay, so later when you work with this, you must go and do the conversion to cm as well. Okay, so first things first, you need to find out what is the volume of one brick first. Okay, so length times base times height. Okay, 18 times 9 times 6. This is a cuboid. Okay, essentially this brick is a cuboid. Okay, work out the volume. We got 972. Okay, step 2. Okay, convert these meters to cm. Okay, next, I need to find out what is the volume of the wall that I'm building. Okay, so same thing. This is a rectangular wall. Okay, volume, this is a cuboid as well. Okay, length times base times height. Or length times breadth times height. Okay, 450 times 360 times 18, you get this volume here. So number of bricks required, just take the volume of the wall, divide by the volume of one brick. You get 3000. That's it. Okay. Okay, next, let's take a look at an example where we are calculating the amount of paint required. Okay, so remember for paint, this we are talking about surface area of the solid itself. Okay, so you have a dustbin, okay, with A, B, 20 cm, okay, B, C, C, they give you the different lengths essentially. Okay, find the volume of one dustbin. Okay, so when you look at this dustbin, you have never learned the formula for such a shape, right? For volume of such a shape. Okay, so what you can break it up into, okay, essentially, okay, I can break it up into this triangular prism, okay, that I'm highlighting for you here, as well as the cuboid that you have here. Okay, so volume of prism, okay, always have cross-sectional area times height, right? Okay, so let me erase this so that you can see the length clearer. Okay, so your height of your triangle is 18. Okay, your base is 20 cm. So half times 18 times 20 times the height of your prism here, which is this length here of 30 cm. Okay, you get this volume. Cuboid, very straightforward. Length times breadth times height. 20 times 30 times 50. Okay, you get 30,000. Okay, from there, just sum up the two volumes. Okay, you get the total volume of the figure itself. Okay, this one should be quite straightforward. Okay, part B might be the one that's a bit more troublesome. Okay, each dustbin excluding the base. Okay, so this is important information, which means they are not going to paint the base of the dustbin itself. Okay, it's to be painted green. Given that Town Council intends to paint 180 such dustbins with tins of paint, each able to cover an area of 20 meters square, find the minimum number of tins of paint that the Town Council must buy. Okay, so informations that are important. I want to paint 180. Okay, each tin of paint can cover an area of 20 meters square. I want to find the minimum number of tins of paint that I need. So first things first, I need to identify for one dustbin, how much paint do I need? Okay, so I need to find the total surface area of one dustbin. Okay, so your surface area, you have a few sides. Okay, your cuboid first. Okay, 50 times 30. 50 times 30, and I have two sides of it. That's why it's 2 times. Same thing, 20 times 50. I also have two sides of it. Okay, then you have this 24 times 30, which is this rectangular side as well as the other slanted side. Okay, these two sides. Lastly, you have the two triangular faces, which is the base area or the cross-sectional area of the prism we calculated earlier. Okay, you end up with 6,800. Okay, then next I have to find out if I want to paint 180, how much I need, right? So 180. Okay, so now we find how much paint we need in total for 180. So just take this value here, multiply by 180, you get this value here of 1,224,000. Okay, then because the area for the tin of paint, they give me in meter square, I need to convert this to cm square. Okay, so if you remember your conversion from meter square to cm square, okay, you just square the entire 1 meter is 100 cm because 1 meter is 100 cm, right? So I'll square. Okay, 100 square is 10,000. Okay, so 1 meter square is equivalent to 10,000 cm square. So if I have 20 meters square, I just multiply the value by 20, I will have 200,000 cm square worth of paint in one tin. So you just divide the total surface area of 180 dustbins, okay, over how much paint you have for one tin. Okay, you get 6.12. Okay, so this is not a whole number, right? Obviously, when I buy paint, I cannot buy 6.12 of a tin. Sorry, 6.12 tins of paint, correct? So in this case, okay, important, you need to round up instead of rounding down. Because if I buy 6, I will not have enough to finish 180. Okay, but if I buy 7, I will have enough, although yes, I will have leftover. Okay, so your minimum number of tins you just round up, you will end up with 7 tins. Okay.